Good evening, everyone. Today we are going to look at resistance or resistance. It was supposed to be a resistance, not a resistance. So a resistance in series and parallel. So the first thing we need to know what a parallel. When a circuit is connected in parallel and when it is connected in series. So how can you know that this is connected in series? How do you know, or how can we know? So I'm going to give you an example. We can say when it is connected in series. For example, I can say we have this as our circuit. You have one battery. I have maybe voltage, say 12 volts. Then we can do this. We can say here we have current. We can do this. Maybe there we have what as our bulb there. So this one means that it is connected in series because the voltage there or the current which is passing through there is the same. But the one which is in parallel, this is series. But the one in parallel, you can say parallel. It's like this. For example, when we say maybe we have current here, then you find that there is this. Maybe have another resistance there. You can say R. Maybe say resistance. And there maybe have another resistance. There we can say this. We can say this is connected in what? In parallel. Because the current which is being there is what is being shared. The other current is going there, the other one is going there. Maybe to extend this, maybe we say here have a battery, maybe two batteries. We say this. We say this. Maybe these are the batteries that we have. Maybe they are the voltage. Maybe you say it's again 12 volts. So we can say in series, when the circuit is connected in series, we can say voltage is not the same at any point, but current is the same since current is not shared. But in parallel, current is not the same because it's shared, but voltage remains the same. So here we have a question saying find the total resistance in the three resistors connected in series. So this question says it is connected in what? In series. So how do we find the total resistance when it is connected in a series? How do we find the voltage, the resistance? So we can say question 1. We can say total resistance by saying T, or can say or small t or big T if you want. You can say total resistance is equal to, just add the resistance that we have here, 12, 4, and 6. So you can say, by writing our formula, you can say resistance 1 plus resistance 2 plus resistance 3, because we have 3 resistance there. Then we are going to say 12 resistor plus 4 resistor plus 6 resistor. Then if you add this 6 plus 4, 12 plus, or we say 6 plus 4 plus 6 is 10. 10 plus 12 is 22. So you can say 12 resistors. So this is our final answer when it is connected in series. So find the question 2, find the total resistance. Find the total resistance. So if we see there, this in this diagram here, we can say that this is connected in parallel, because here this line, which means there was current, when the current reached at this point, it was being shared, it went there and there, so it was shared. So the formula that you can use, we can say question 2, we can say to find our total resistance when it is connected in parallel, we can say 1 over total resistance is equal to 1 over, according to our resistance, how many do we have? 1, 2, 3, we have 3 resistors. We can say 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3. This is the formula when it is connected in what? In parallel. So now our question of 12, 4 and 6 resistance. So we can say 1 over total resistance is equal to 1 over, we get 4, this one. We can say 4 plus 1 over another resistance, we can say we have 12 plus 1 over resistance 3, we have what? 6. Then what do? The thing that we're going to do here, we can find the common denominator there. If you want, you can use a calculator direct. You are going to find the correct answer. But let's find our common denominator there. We can say we have 12. We look for a number where 4, 12, and 6 can enter without leaving a remainder, and it's 12. And we say 4 into 12, it's 3. 3 times 1, it's 3, plus 12 into 12, 1. 1 times 1, it's 1, plus 6 into 12, it's 2. 2 times 1, it's 2. Remember here we have 1 over total resistance. So you can say 1 over total resistance is equal to 3 plus this, it's 4. 4 plus 2, it's 6. 6 over 12. And this in the lowest, we can say it's 1 over 2. If we divide 6 into 6, 1. Into 12 is 2. So there we can say we have 1 over total resistance is equal to 1 over 2. We want to find the total resistance. We're going to do cross multiplication, where we can say total resistance times 1. It's total resistance, the same this thing. Then we can say 2 times 1. It's 2. 2 what? Resistance. So this is our answer. So this is how you find the resistance when it is connected in parallel. So this is the formula. So according to the resistance that you have in your question, I'm going to name them resistance 1, resistance 2, resistance 3. If you have 6, just continue there going where? To 6. But when it is connected in series, just add them. Just add them. And we have another question. Question 3. Let's look at question 3. They're saying, find the total current passing through the circuit. The total current passing through the circuit. So we have seen this circuit that we have there. They are saying, have these 4 resistors. Here, the current, this is the voltage that we have there. This is the voltage. For example, let's just say maybe this voltage, it's 12. Say it's 12 volts. Then we have this resistor. This means that the current which is flowing there, this one is connected in series, because current which is coming from there isn't shared, just going direct there. But this one, current when it reaches there, it's going to be what? Shared. And the voltage remains the same when it is in parallel. But there we have what? The voltage that can be different as there. There you can at this 12 resistance, the voltage is 12. At this 6 resistance, the voltage is 12. But on this 4, it's not equal to 12. That's the law. The law says in series, when it is connected in series, current is just the same at any point. But when it is connected in parallel, current changes, isn't the same. So look at this question. I'm saying find the total current passing through the circuit. The current. Remember, we said we have this formula which we said, say question 3. We said that resistance is equal to voltage over current. We want to find the resistance. So let's look at our question. We have for the first we need to calculate the total resistance connected in what? In parallel. We have 12 there. We also have 6 there. So you can say 12 and 6. So our solution, first we find the total resistance in parallel. So you can say 1 over total resistance is equal to 1 over resistance 1 plus 1 over resistance 2. We have 6 and 12 resistance. So we can say this is equal to 1 over the 12 resistors that we have plus 1 over the 6 resistors that we have. We look for a common denominator, it's 12. We say 12 into 12, 1. 1 times 1 is 1 plus 6 into 12, it's 3. It's 2. 2 times 1 is 2. So you can say here we have 3 over 12. So there now we can say, if you come back down there, we can say 1 over total resistance is equal to, when this comes in the lowest term, it's going to be 1 over 4. 1 over 4. Then how do we calculate the cross multiplication? You can say total resistance is equal to 1 times 4. It's 4 resistance. Now that we have these 4 resistance, what do we need to do? This is the resistance which was connected in what? Parallel. Now what of this in series? The 4 there that we have. So we're going to add the total resistance that we have there plus this one. So that 4 resistance that we found, just the same, like just make just one line there cutting this, and we say we have 4 resistance there. That's what we do. So we're going just to add 4 plus 4 resistance that we have here. So now we can say, therefore our total resistance is equal to 4 resistance, this one plus the one which was connected in series. It was 4 as well. So we have 8 resistance. Now our question is saying find the current. So using our formula, this one, we can make I the subject of the formula by saying resistance is equal to voltage over current. Resistance equal to voltage over current. Remember, our current, total current, it's 8. We can say 8 is equal to voltage, it was 12. to our question if you check clearly there. Over or divided by current, and it's the one that we are looking for. Then here you can see there is one, we cross multiplication there, we do cross multiplication. Then I'm going to say this one times this one, it's 8. I is equal to 12. Then we divide, they are going to say we divide by 8, we divide by 8. Say this current is equal to, when you we simplify this or reducing this, you can say 4 into there it's 3, 4 into there it's 2.